So having understood about the definition of fluids and having also understood about the compressibility factor about liquids and gases, let us now try to know more about liquids and gases. Now let us come to gases. Of the fluids that we call gases and liquids, let us see first gases and then we will come to liquids. Let us see some features for gases. Gases, as we all know, we got ideal gases which basically obey ideal gas law, and the ideal gas law is simple equation of state, which is PV is equal to RT. When I say that they obey simple equation of state, they also obey the basic laws of the gas, which is Boyle's law, which say PV is equal to constant when temperature is constant. Then we got a Charles law, and also we got a Joule's law when we say thermal energy is a function of temperature only. These are very simple gas laws. Based on this simple gas law, we have got a simple equation of state for gas, and for any given pressure and temperature condition, I can know all the properties of these gases. So once I know that a particular thermodynamic state space is at a particular pressure and temperature, I will know all the properties of that system. Now if I go away from ideality, I will have real gases at very high pressure, at very low temperatures, and let us see real gases. They do not obey the ideal gas law, that is what we know, and therefore what they have is real gas law, or we have complex equation of state. What we had earlier was a simple equation of state, and there are various complex equations of state now. We got van der Waals, we got a Berthelot, we got Redlich-Kwong, Beatty-Bridgman, BWR, Strawbridge, Virial. So there are several equations of state which actually connect the properties of real gases. So again, as I said, for ideal gases, if I know the pressure and temperature, I can get all the properties of the gases. Similarly, even if the gas is now real gas, it is away from ideality, still using this real gas equation, I can again compute all the properties of those gases, in spite of the fact that the gas happens to be a real gas. Now let us go to liquids. For liquids, unfortunately, we do not have any equation of state. So for the gases, I can compute all the properties using equation for ideal gas law or real gas law. I do not have any such equation of state available for liquids, and this is a very important difference between these two fluids, the gases and the liquids. So how do I get properties of the liquids? If I know at least a few properties, let us say pressure and temperature, how will I get other properties like specific volume, density, etc. So what do I have? I conduct a lot of experiments. So it is very important for liquids. I do not have any equation of state, and therefore what I have got is basically experimental data. So I conduct experiments at various important points, important pressures, important temperatures, and acquire data at those points. So I may do something, for example, for water 0 degree centigrade, 100 degree centigrade, some important temperatures and pressures, 1 bar, atmospheric pressure, 10 bar, etc., and get all the property data at those points. Once I get those points, I can then have intermediate values using property relations. In thermodynamics, we have got several property relations that are available, Maxwell property relations for example. Using such property relations and using this experimental data point, I can get approximate data for other points also by using some interpolation, etc. More experiments I do, I can get more data, but I cannot do experiment at all the points. So the important difference between the gases and the liquid is, here I have to conduct lot of experiments in order to get more realistic data, while in gases I need not do experiments, I have got equations of state over there. With this background, after understanding the difference between the gases and liquids, as this is an introductory lecture, I would just like to show different applications of fluids. In engineering, we have got, in mechanical engineering specifically, we have got several applications of fluids, and when I say fluids, I am referring to gases and liquids. So various applications are in automobile, what we have is a petrol or diesel. Aircraft, again we have got a fuel. Spacecraft, again we have got a fuel which could be in liquid form, which could be in gaseous form also. Also we have got air compressors, we got steam turbine, we got electric water pump, alright. So, these are all various major engineering applications in mechanical engineering which actually solely depends on fluids, and therefore, they will be governed by the properties of the fluid. If I want to design a compressor, I need to know the properties of the fluid, properties of the air at those pressures and temperatures for which I am designing, and this is what for we should know all the applications of the fluids, because our devices are going to be designed for those property data. Similarly, we have got refrigerator, where refrigerant is also, it could be in liquid form, it could be in gaseous form. Then we got nitrogen devar, where liquid nitrogen could be stored. We got a helium balloon, we got air conditioner, where refrigerant again plays a very important role. So, these are different applications of fluids that we come across in mechanical engineering, and if you want to design these devices, we ought to know the properties of the fluids at different pressures and temperatures, and therefore, this topic has its importance from this design perspective of various devices. So, what have we learned in this introductory talk? We have understood that liquids and gases can flow, and that is why they are called as fluid, or the fluid definition is basically because of the fact that liquid and gases can flow, while solids cannot flow, and therefore, they are not qualified to be called as fluid. Gases are compressible, while liquids and solids are assumed to be incompressible. We have also seen about the difference between ideal the gases and the liquids. The ideal and real gases, we have got equation of state, while for liquids we do not have equations of state available, and with what we also saw was different applications of engineering fluids.